Hello everyone, this is Sanjay from CSVT branch. Today my Aat Tech Talk topic of image processing is privacy preserving image processing in the cloud. Millions of private images are generated in various digital devices every day. The consequent massive computational workload makes people to turn cloud to computing platforms cloud computing platforms for their economical computational resources. Meanwhile, the privacy concerns over the sensitive information contained in the outsourced image data arise in public. In fact, once uploaded to the cloud, the security and privacy of the image content can only presume upon the reliability of the cloud service providers. Lack of assuring security and privacy guarantees becomes the main barrier to the further deployment of cloud-based image processing systems. This paper studies the design targets and the technical challenges lie in constructing cloud-based privacy-preserving image processing systems. We explore various image processing tasks including image feature detection, digital marking, content-based image search. The state-of-the-art techniques include secure multi-party computation and homomorphic encryptions are investigated. A detailed taxonomy of the problem statement and the corresponding solutions is provided. Privacy-preserving image processing in the cloud is a critical concern. Is more and more personal and sensitive data is being stored and processed in the cloud. This this approach aims to perform image processing while safeguarding the privacy of the data being processed. Here are some of the techniques and strategies to achieve privacy preserving image processing in the cloud. The first one is homomorphic encryption. Homomorphic encryption allows computations to be performed on the encrypted data without decrypting it first. In the context of image processing, it can be used to perform operations like image filtering, enhancement, or analysis on encrypted images. Results can be sent back to the user without exposing the original image. Secure Multi-Party Computation (SMPCs). SMPC enables multiple parties to jointly compute a function over their inputs while keeping these inputs private. In the cloud, users can use encrypted images and request processing operations without revealing the image content. The cloud server performs the operations without having access to the unencrypted image data. Referential privacy. This technique adds noise to the image data before processing, ensuring that the processed results do not reveal specific details about individual images. It offers a trade-off between privacy and utility, as some loss of accuracy in processing may occur. Federated learning. In this approach, the image data remains on the user's device. The model is sent to the cloud, and the cloud server aggregates the model updates from multiple users. This way, the raw data never leaves the user's device, and only aggregated updates are shared with the cloud or image processing. Secure enclaves. Cloud providers often offer hardware-based secure enclaves like Intel SGX or AMD SEV that can be used to protect image data while it is processed in the cloud. The data remains encrypted within these enclaves, and processing occurs within a trusted environment. Data minimization. Limit the amount of data sent to the cloud for processing. For example, you can process only specific regions of an image that are relevant to the task while keeping the rest of the image on the user's device. Zero knowledge proofs. Zero knowledge proofs allows a party to prove to another that they know a specific piece of information without revealing the information itself. This can be used to prove that a certain image processing operations was performed correctly without disclosing the image content. Use trusted execution environments like leverage cloud services and platforms that support these. such as Azure Confidential Computing or AWS Nitro Enclaves. These provide a secure environment for processing data without exposing it to the cloud provider. Policy-based access control. Implement fine-grained access controls and data usage policies to restrict who can access image data and under what conditions. This can prevent unauthorized access and data leakage. Secure communication. Ensure the data is transferred and to form the cloud securely using encryption, and use secure channels like HTTPS for communication. Motivated by the rapid growth of image processing and data mining techniques, more and more image processing based applications are deployed in various end user devices. For example, content based image search, digital watermark verification, and so on. The consequent massive image processing task brings enormous computation overhead to data owners. To solve these problems, more and more users are outsourcing the expensive tasks to cloud computing platforms. In such cloud computing platform, cloud service provider CSPs offers a pay-per-use business model which enables individual users to use robust computation power in cloud while saving time. So in figure 1 we can see the system model, cost and setting on corresponding infrastructures. In fact, not only individual for small business data owners refers to internet giants like Microsoft and Yahoo are also attracted by the benefits bought by cloud computing and authorize some services to third-party cloud computing platforms. For example, several types of data searching tasks in Microsoft Bing have been outsourced to Wolfram. So the system model as shown in the figure, as shown in the figure, the proposed system consists of two main entities: cloud computing platforms and user. User is a data owner who holds massive image data and intends to outsource the image processing task to the CCP. Under this setting, a user utilizes the CCP as complementary resources for its limited computational power and outsources complicated image processing tasks to the CCP. Meanwhile, users also need to protect the privacy of data. For example, hospitals are under the obligation to protect the patient's records like medical images and profile. In this case, to protect a user's privacy, he or she has to encrypt the image data before outsourcing to the CCP. Meanwhile, the entity CCP is composed by a set of cloud servers. It is assumed to be honest but curious. It can only access the encrypted image data uploaded by users and perform corresponding image processing algorithms. So the workflow, the proposed system consists of two main phases as follows, like data processing and data pre-processing phase for image. So so the design targets are: after the building the system model and define the workflow, we formulate the design targets in constructing a privacy preserving image processing mechanism on cloud. The first design target should be functionality, which requires the proposed system to perform image processing algorithms and generate corresponding results correctly. The second design target should be security, which requires the proposed system to protect image contents confidently against the CCP while performing the process algorithms on ciphertext. So like in this diagram we can see how the RGB histogram of image, and this is called a histogram, and number of bins, so that like allocate each pixels to the bin. We use the image feature detection algorithms as a set of case studies to analyze about three different targets. So and also here we can see like there is a source images of this. So finally I can conclude that implementing privacy preserving image processing in the cloud requires a combination of encryption techniques, secure computing environments, and access controls. The choice of method depends on the specific use case, the level of privacy required, and the computational resources available in the cloud environment. It is also crucial to adhere to data protection regulations and standards to ensure com- uh, compliance with privacy laws such as GDPR and HIPAA. Image processing and cloud computing platform which could be enable any fancy image processing based applications and devices with limited computation power. So these are some of the references of my image processing tech talk. Thank you.